This is your lesson for 13.2. It's titled Areas of Trapezoids, Rhombuses, and Kites. There are 3 different figures we're going to learn about and their formulas to find the areas of them. So the first one is the area of a trapezoid. In this picture you see a trapezoid. Remember that a trapezoid's opposite bases are parallel to each other. So base 1 and base 2, they're labeled B1 and B2. And then you have a height, and the height is usually going to be on one of the sides that makes the shape of a triangle, but we're not going to use the triangle unless we need to figure out what the height is. So sometimes they'll give you the length of the slanted side right here, and then they'll give you this side, and you can use the Pythagorean theorem to find the height of the actual trapezoid. So the area of a trapezoid is just half of the height times the sum of the bases. So basically you add the bases together and then you multiply them by the height and divide them by 2. So this is the equation for the area of a trapezoid. Okay, so here's the theorem sorry about that, the area of a rhombus and a kite. They fortunately have the same equation to use, or the same formula to use, so that's nice. D1 and D2 stand for the 2 diagonals, so diagonal 1 and diagonal 2. The order doesn't matter. And so for a rhombus, you will multiply their diagonals and divide them by 2, and then for a kite, you would do the same thing. Our first example we're going to do is finding the area of this figure to the right. On this figure we have basically here with the information that I'm providing you, this is a trapezoid. To find the area of a trapezoid, it is base 1 plus base 2 times the height divided by 2, or times 1/2. So basically what we're going to do in this particular question is add 205 to 511 times that by 309 and divide that by 2. And if you plug that into a calculator and get the final answer, you will get 110,600 miles squared. Remember that we're doing area, so we have to square our units. The next example is an example where we're trying to find the area of another trapezoid, but this time we don't know the height. We know the bases, and we also know this angle right here. So if we were to draw our height here, this would make a right triangle. Fortunately, we do know that this is 7 minus 5, so that's 2. And in this case, we have a 30, 60, 90 triangle, so that means that the side opposite 60 is x square root 3. I can also use trig if I want to, but I'm going to make it easier on myself and just use 30, 60, 90. So opposite 30 is 2, which means that our height is 2 square root 3. So there's our h. Now we're just going to plug it into our formula. So 1/2, or you can save that for later, height, which is 2 square root 3, times the bases added together. Remember, the order of that doesn't matter. The question in this case, we will just round to basically the nearest square root, so we won't give the decimal. You can if you want to, but in this case we're just going to leave it 7 plus 5 times 2 divided by 2, so that becomes 12 square root 3 meters squared. So basically, again, all I did here was I found the height by using the 30, 60, 90 triangle properties, and then I plugged that into the formula. Next example is finding the area of a kite. So remember that the kite is just, area is just 1/2 diagonal 1 times diagonal 2. So diagonal 1 is 7 and diagonal 2 is 6, or I could have flip-flopped those. So 1/2 times 6 times 7, again, it doesn't matter. 6 times 7 is 42, and divide that by 2, and you get 21. So remember, this is the equation for the area of a kite and a rhombus. Next question is finding the area of a rhombus, and in this case it's a word problem, so we'll want to draw a picture. It tells us it's a rhombus, so if I draw a rhombus, I know that all four sides are congruent, and they're all 10. And then it also tells me that the longer diagonal is 16. Remember that in a rhombus, the diagonals are not congruent to each other, but they are perpendicular. So I'm going to make the thick one my long one, so I'll make that one 16. I know they're perpendicular, which makes that 90. So I need to figure out what this length is so I can figure out that entire diagonal. Now, using the Pythagorean theorem, I'm going to need to make sure that I cut this in half. So I'm going to use 8 x and 10. So basically 10 squared is equal to 8 squared plus x squared, which basically means 100 minus 64. Which turns out to be 36, and so this is 6, which means that my entire length of that diagonal is 12. And then I use my formula, 1/2 diagonal 1 times diagonal 2, and that is 1/2 12 times 16, and that turns out to be 96. And we have centimeters squared. Okay, our last example is a composite figure. In this composite figure, we have a rectangle and we have a kite. And so in order to solve this, we would need to find the area of each. Now, notice also that in this case, the kite is overlapping the rectangle. So it would be better if we split this up into 3 figures, 2 trapezoids, and a kite. The trapezoids on the left and the right are the same, so you could just find the area of one of them and then times that by 2. That would probably be your best bet. And then finding the area of the kite wouldn't be very difficult either. So the area of a trapezoid, this is just for one of them, is base 1 plus base 2, so 6 plus 4 times 3 divided by 2. And then the area of our kite is diagonal 1 times diagonal 2 divided by 2. But there's kind of a problem here because in this kite, I know this diagonal, it's 10, but I don't know this one. However, I know that this is 12, and this was 4, and this was 4. 4 plus 4 is 8, so that makes this 4. So basically I'm going to plug in a 4 there, and then I'm going to divide that by 2. So to finish out my trapezoid, whenever I do all of that math, it ends up being 15 yards squared, and then when I do my kite, that becomes 20 yards squared. And remember that the trapezoid was half, so I have another 15 yards squared that I need to add. So 15 plus 15 plus 20, that's 30 plus 20, so my final answer is 50 yards squared. Okay, so hopefully this is making some sense to you. Of course, if you don't understand it, just come and ask some help in the morning or at lunch or after school. I'll be available. You guys have a good rest of your day, and I'll see you soon.